Good afternoon, everybody. It's once again Ted the Speed Learner, and this is Euclid Book 6, proposition number 25. And I wanted to start off tonight by saying, well, tonight, this afternoon really more like, that the hardest part of this particular proof, yes, granted, I cannot show you the whole drawing in this screenshot. There is no way, it's just too big. However, the hardest part about all this is not so much the proof itself, but how you're going to actually draw it. That's the tough part. Okay? So, how are we going to draw this thing? Well, the key to this whole proof will be found in this statement. Let me read it to you. As BC is to GH, well, here's line BC and here's line GH. So is GH to CF. Okay, here's GH and here's CF. GH is a mean proportional between this and this. That's going to be vital. Now, I'm going to tell you how to draw this thing, because if you ever have to draw this for your friends, believe me, you're going to want to know this information. Now, we're going to make BC 2.25 inches long. We're going to make GH 3 inches long and CF 4 inches long. Well, 2.25 divided by 3 is equal to the same amount as 3 is divided by 4. And as we know, 3 divided by 4 is 0.75. You divide 2.25 by 3 and you'll get 0.75. That is a guarantee. And that is absolutely vital to this proof. Now, how do you form the triangle up here? Well, the base is going to be 2.25. Now you're going to have to form the height. The height has to be equal. This whole area in here has to be the same as this parallelogram down here. How do you do that? Well, we have 2.25 by 1, and as you know, base times the height. 2.25 times 1 is 2.25. Okay? So, the area of this triangle is going to be 2.25. How do you make that? Well, as you remember, in triangles have a base times the height, okay? But that base times the height has to be divided by 2. Okay? It's 1/2 base times the height. So you take the base, you take the height, you multiply those numbers together, you divide it by 2, and whammo bammo, you've got the area of this triangle right here. So, if you take 2.25, which is the base, and you multiply it by 2, which is the height, and then after that, you divide that number by 2, you will get the same area as this. That is a guarantee. Alright? Now, what about this area right here? We have a 4, we have a 1. 4 times 1 is 4. We have to get this triangle right over here, this one right here. It has to have the same area as this. Okay, so how are we going to do that? Well, the base is 3. We're going to have to multiply that by 1/2. Okay? And that makes 1.5, and remember that the area it has to equal is 4. Well, 4 divided by 1.5 is 2 2/3. Now you say, well, how do we get the 2/3 part? Well, 2/3 falls between 10/16 and 11/16. Okay? So when you draw the height of this triangle, you're going to draw it 2 and a little more than 10/16. Let me say that again. You're going to draw this height at 2 and 10/16 inches, but you're going to extend it a little bit further. It's going to be between 10/16 and 11/16. And that will give you the exact height of this triangle. And then you just draw the lines together and whammo bammo. Now, you're also going to have to draw this shape here, letter D. Letter D must have the same area as this parallelogram right here. And believe it or not, this parallelogram will also have to have the same area as this triangle right here. Now, how do you draw D? Well, this was a 4 by 1 parallelogram. So what we did was we made this line 1.5 inches long, we made this line 1/2 inch, and we made this one 4 inches, and we just connected the dots here. That's how we got D. But D has the same area as this. Guaranteed. Alright. Now that we know how to draw all this, so that it works exactly the way it's supposed to, now we can actually get into the proof. Let me read it to you. Proposition number 25 says to construct one and the same figure similar to a given rectilineal figure and equal to another given rectilineal figure. Let ABC be the given rectilineal figure. Boom. There's ABC right there. To which the figure to be constructed must be similar. And D to that which it must be equal. That D right there. Thus it is required to construct one and the same figure similar to ABC. The figure that we're going to draw is similar to this and equal to this. It's similar to this and it has the same area as this. Here we go. Let there be applied to BC the parallelogram BE. Well, here's the parallelogram BE equal to the triangle ABC. So basically, this area here is equal to this area here. Okay? And this is by Euclid Book 1, proposition number 44. And to CE, the parallelogram CM equal to D and the angle FCE, which is equal to the angle CBL. Well, okay, we've gone too far with this. We have to have, we're going to attach to CE here, this line CE, we're going to attach another parallelogram, and it's going to be known as CM. Okay? And its area has to be the same as this. Okay? And FCE, this angle right here, okay, has to be equal to CBL. This angle here and this angle here, they're both 90-degree angles, so they're equal. And this is by Euclid Book 1, proposition number 45. We'll want to check that out. Therefore, BC is in a straight line with CF. BC is in a straight line with CF. And LE to EM. LE to EM. Now let GH be taken as a mean proportional to BC and CF. GH is a mean proportional between BC and CF. This is by Euclid Book 6, proposition number 13. And on GH, okay, let KGH be described similar and similarly situated to ABC. So on GH, we're making the triangle KGH, okay, and it's going to be similar and similarly situated to ABC by Euclid Book 6, proposition number 18. Then, since as BC is to GH, line BC, line GH, so is GH to CF. Okay? We've already established that. And if three straight lines be proportional, this to this, and this to this, as the first is to the third, so the figure on the first to the similar and similarly situated figure described on the second. This is by Euclid Book 6, proposition number 19, porism. Therefore, as BC is to CF, so is the triangle ABC to the triangle JKH, or JGH, sorry. So as this is to this, so is this is to this. But as BC is to CF, so also is the parallelogram BE to the parallelogram EF. BE, EF. This is by Euclid Book 6, proposition number 1. Therefore, also as the triangle ABC is to the triangle KGH, so is the parallelogram BE to EF. Therefore, alternately, as the triangle ABC is to the parallelogram BE, so is triangle KGH to EF. This is by Euclid Book 5, proposition number 16. But the triangle ABC is equal to the parallelogram BE. What that means is the area inside of here is equal to the area inside of here. Therefore, the triangle KGH is also equal to the parallelogram EF. The area in here equal to the area in there. And this is by Euclid Book 5, proposition number 16. But the parallelogram EF is equal to D. This is equal to D. Okay. Therefore, KGH is also equal to D. KGH is also equal to D. And KGH is also similar to ABC. We've already established that. Therefore, one and the same figure, KGH, right here, has been constructed similar to the given rectilineal figure ABC. So this is similar to this. And equal to the other given figure of D. So it's similar to this, but it's also equal to that. Wow! All right. I think you've had enough for tonight. I know I have. I will tell you more in a future video, so stay tuned.